Hi, I'm Tanja Hayes. Let's learn some more economics. Today we're going to talk about perfect competition and specifically profit maximization inside of the world of perfect competition. So first, let's think about what do we mean by perfect competition. It's the kind of setup where the following three things are true. And it's hard to find an exact example of this because it's very exaggerated, but that's okay. We can kind of imagine. So first of all, we have many buyers and sellers. This is unlike, for example, a monopoly where you have just one seller, or a monopsony where you have just one buyer. We have many buyers, many sellers. No one's that important compared to everyone else. We have identical products. So maybe we are selling apples at a farmer's market and every apple looks the same, and so people walking around can just pick any of these apples. Ours are no different than the rest of them. And lastly, there are no barriers to entry, meaning that if somebody else wants to join in and start selling in this market, they can. So maybe they can also grab a basket of apples from their yard and just start selling it. So that would be kind of the example world we're living in. Okay. So if we are living in the world of many buyers and sellers, that means we have supply and demand that we're dealing with, as we know from previously perhaps in economics. So we're going to start out by imagining the market. And when we say market, we just mean everybody, all the buyers and all the sellers. The market for apples. There's going to be demand, D, and there's going to be supply, S. And we know we have quantity on our x-axis and price on our y-axis. And what's this right here? Equilibrium. So wherever supply and demand cross, we're going to have some equilibrium price. We know that from before, right? Okay, so we are now going to think about this market equilibrium price that happened and translate that into what does it look like for the individual seller, the individual firm or company or person, whoever that might be. So regardless of the size, we are calling that the firm. And so it could be one person, it could be Walmart, corporation, whatever it might be. Okay, and so for the firm, we are going to think about this price that happens in the market is the price that then we are selling for. So that price, whatever it translates to over here, this equilibrium price is also our marginal revenue per unit because we can sell every single apple for that amount. If it's $2, then no matter the quantity, the marginal revenue for the next apple is always that same amount of $2 or whatever it might be. So that's our marginal revenue. Marginal revenue. Okay, so we have a marginal revenue a marginal revenue curve. Thinking ahead here because we're going to add a cost curve to that. So we're going to add our marginal cost curve. Do we remember what that looked like? Kind of like a check mark, mostly going up. There's our marginal cost curve. Marginal cost. That Q turns into a G and it's legible. Okay, so the only other thing we're going to need to add to figure some stuff out about profit maximization is our average total cost curve, because that's going to also tell us what's it costing us on average. But we'll do that in a little second. So the market, supply and demand, determines the price. That price is then what each individual person or firm can get per apple. And so now, as our little firm here of selling apples, we got to figure out how many apples are we going to sell. Well, the profit maximizing rule is, what is it? Produce the quantity where marginal cost equals marginal revenue. So where those two cross. So that's right here. Let's call that Q star because it's our best quantity. That's how many items we should sell. Now, we're not putting numbers on here, but you can imagine this is a number line. This is some actual number. Okay, now, are we making any profit here? And if so, how much? In order to figure that out, we need that average total cost curve added as well. So I'm going to put that right here for now. We know it's a smiley mouth looking character, this average total cost, and it is intersected at its bottom by the marginal cost curve. So that's what it looks like. Okay, so now we are producing this many units, and we're getting this price per unit. And how much is it costing us per unit? That's what the average total cost curve tells us. So we're getting this much per unit, but it's only costing us this much per unit. So that difference is our profit per unit. So for every apple we sell, we make this much money, whatever those numbers would be. If we want to figure out our total profit, we would take our profit per unit times the number of units, which is the quantity here. So on the graph, it kind of becomes like the area of a rectangle because we're getting profit per unit times the number of units. That's like a base times the height. So the profit really becomes the area of this rectangle here. So that rectangle is our profit. And if we had specific numbers here for what was the price, what is the average total cost? And then what is the quantity? We could figure out our actual profit because we would be using a little rule or formula basically that would take the price that we're getting, subtract off the average total cost. So this would be our profit per unit times the number of units. So that's what is represented by that little shaded rectangle. Okay, so we are making a profit. Great. Let's see what happens next. So here is the firm. It is making a profit. And remember, this is perfect competition. Remember those 3 rules? The third one was there are no barriers to entry. So in our little example of the farmer's market, people selling apples, somebody sees that, hey, people are over there selling apples and making a profit. I'm going to grab some of my apples from my tree and come sell them too. So more people enter into the market. And the market is over here, and we might remember from learning about supply and demand that if more producers enter the market, that means that the supply curve is going to shift to the right, towards higher quantities. So we are going to have a new supply curve that we're going to call S2, because there was a profit, more producers enter the market. So let's say that happens. So now we have our new supply curve, so old, new. And what happens to our equilibrium price? Well, that goes down, doesn't it? So now we have our new equilibrium price, PE2, because those producers came into the market. So then what happens for me and my original little firm where I'm selling apples? I was making a profit, but now these other people came in, drove down the price basically. So now instead of dealing with this price, I'm down here at this new lower price, PE2, we'll call it. Yeah. That looks like Pez. That's too delicious. I can't concentrate. Okay, PE2. Okay, so now this is the price. This is therefore the new price, therefore the new marginal revenue curve, right? And so now here we are facing this new blue curve. We still have our same marginal cost curve and everything. So now if we're going to figure out what should we do now, well, produce where marginal cost equals marginal revenue is always the deal. So that would be at this new spot here. Marginal revenue equals marginal cost. So we would have a new lower quantity that would be good for us at this lower price. And the way I drew this, what's going on at this new price with our profit? Remember, profit is going to take our revenue, subtract off the cost. So per apple, we're getting this price amount. And how much is it costing us per apple right there? Well, the average total cost is basically the same. So those two are equal. So it's costing us the same as what we're taking in revenue. So we're breaking even. So no profit or zero profit as we call that. So the conclusion in perfect competition is that if there is a profit to be made, others will enter in, drive down the price until there no longer is a profit. Now, it might sound crazy to have zero profit, but remember, this is economics, not accounting. So in economics, we include opportunity costs in our costs. So that means that if I'm selling these apples and I have my costs figured out, they include my opportunity cost of what I could have been doing with that time. So if I'm losing out on a salary, that's part of the cost of the opportunity cost. So if I'm making zero profit, that means I'm still able to pay myself what I would be able to make somewhere else. So I'm breaking even compared to any other option. And so, again, the conclusion being that in the long run, in perfect competition, when everything is kind of settled, there will be zero profits in the long run. And we will be producing right here at the minimum average total cost. And that is called efficient. We are not producing at high cost, we're producing at low cost. And that's the conclusion of perfect competition and profit maximization. See you soon.